Let's build this circuit and then use it to take some measurements. So first of all, we need a 9-volt battery. Here we have it. And we're going to connect it into the circuit using this battery clip. So we just clip it on. Let's secure the ends onto our circuit board. So this is the positive terminals connection. And we make sure it's nice and firm there. And then here we have the negative terminals connection. Make sure that you have the bare wire underneath the screw and that it's nice and firm. Now you can see that we're going to use an LED, a light emitting diode. Here is an LED. You can see that an LED has 2 legs, a longer one and a shorter one. The longer leg must be connected to the positive side of the circuit, the shorter leg to the negative side of the circuit. We are going to put the LED into this position here. So the short leg must be connected there to the negative part of the circuit. You can see here I've painted the positive leg with a bit of red paint just to make it easier to see. Sometimes when you've bent the legs like that, it's a little difficult to see which one is long, which one is short. Another way to know which one is the negative terminal is if you feel along the base here. Over there, there's a flatter section. The rest is round, but that part is flatter. And the flat part is connected to the negative leg, the short leg. You can see the symbol of the LED also has a direction because it's an arrow with a light coming out. The light coming out is what the L and the E stand for. L stands for light and E stands for emitting. Emitting means giving off. The D stands for diode, and the word diode refers to a component which has direction, meaning you cannot just connect it any way in the circuit. You have to connect it correctly, otherwise current will not be able to flow through the circuit. It will act like an open switch. And that's why all diodes have an arrow as part of their symbol. And you can see that the arrow's direction must be in the direction of conventional flow, from positive to negative. So let's connect the negative terminal of the battery to the short leg, the negative side of the LED. And we make sure that we tighten it nicely so that there's a good connection. Feel there, yes, good connection. Then this leg is going to go under this screw. There's going to be another component as well, so we'll just wait before we tighten it. Be careful that that paint does not go under, because the paint is an insulator, so that would cause a problem. But we don't need to worry because you can see that the paint is not extending as far as the screw. So we have connected the negative terminal of the cell to the negative side of this LED. Our next step is to connect the LED to a 1K resistor. That 1K stands for 1000. K stands for 1000 ohms. Here we have a 1K resistor. The color bands of a 1K resistor are brown, black, red. There's a gold band after that. It doesn't have to be gold. The gold tells us the tolerance, the degree of accuracy. But the brown, black, and red stand for 1000 ohm, 1K. Now let's just double check that this really is a 1K resistor. So we're going to use our multimeter as an ohm meter. An ohm meter measures resistance. An ohm meter must be connected across a loose resistor. The resistor must not be part of a circuit. So we're just simply going to place these probes across the resistor like that. But obviously we first need to turn the multimeter dial so that it acts as an ohm meter. You can see over here, this is the range where it's acting as an ohm meter. We can see the omega sign there for ohms, and here K for kilo ohms. Now where should we place the dial? Obviously it must be somewhere within this area, but where exactly? That would read up to 200 ohms. That up to 2000 ohms. Now we know that this is a 1K resistor, so that should actually be the right setting. But let's start on the 200 ohm maximum setting and see what we see. So we place the probes across this resistor, and you can see we get a 1 reading. It doesn't mean 1, it means that the setting is not right. So then we move the dial, and there we get a reading. And we get 973. Changes a bit, 971. Well, what shall we say? 972. Let's take it as 972. So this tells us it's 972. What is the unit? Because we have it on this setting here with the omega sign, ohms, the unit is ohms. So this seems a bit strange because I said 1K means 1000 ohm. 1000 is the same thing as K. But what you must realize is that there is always some manufacturing error. So when they say that it's a 1000 ohm resistor, it's very unlikely that it is exactly 1000 ohm. And you can see that 972 ohm is not that far from 1000 ohm. We could round it off to 1000 ohm maybe, and that is what they've really done, I suppose. Now let's take the reading on the setting just above that, reading to a maximum of 20K, and this setting will give the answer in the unit kilo ohms. So let's see what we get then. And we get 1,00 ohms, 0,99. Okay, let's take that, 0,99. So in kilo ohms, we found it's 0,99 kilo ohms. Now, isn't this a little strange? Because 972 is actually, if we don't go rounding off, if we just get the exact conversion, is 0,972K. So we shouldn't have got a reading of 0,99. We should have got a reading of 0,972, or let's round off, 0,97 at least. So why are we not getting that? We must remember that this multimeter also has some inaccuracy in it. All meters do. And so the fact that we get a slightly different value when we measure in this setting, you see it's even changing, now it's 0,98. And when we measure in this setting, is not serious. It's just part of experimental error. It's part of, in this case, instrument error. And we've also seen manufacturing error because what they say it is and what we measure it to be are not identical. So we must just round off, and we must round off quite generously actually, and just say that is 1000 ohm, 1 kilo ohm. And the little bit of difference that we've found, we just ignore. So now we need to connect the 1K resistor to the long leg of the LED. And so we place the long leg of the LED together with one side of the 1K resistor, and then make sure that that is tightly screwed in place. Maybe give a little tug there. Yes, that's a nice connection. And this side also a good connection. So there we have the 1K resistor in position. So all we still need to do is to connect the other side of the resistor by a good conductor to the positive terminal of the cell. Now we can do that in many different ways. We can use wires like that. It doesn't matter the color. That's got green insulation. This has got red insulation. It doesn't make any difference what color of insulation we use. But I'm just going to make it very simple, and I'm going to use a crocodile connector. Connect there, and then connect here. And we can see that the LED does indeed shine. If your LED does not shine when you build the circuit, just check that you have got the legs of the LED the right way round, where the short leg is connected to the negative terminal and the long leg is closest to the positive terminal of the battery. So here we have our complete circuit.